So today we have taken up a problem from mathematics, not from physics, mind you students, from IIT Advanced 2026 question paper. At first, let me just read out the problem. Though let me assure all of you that it's quite an easy problem. Let y belong to the open interval minus infinity to plus infinity. Of course, with infinity being in discussion, it will have to be an open interval. And x belonging to the open interval, open on both sides, 0, infinity, be the solution of the differential equation dy dx equal to e to the power 5x into y cube plus y cube divided by e to the power x plus e to the power x into y to the power 4, satisfying the condition that y at x equal to 0 is 1 by root 2. Then the value of y log of 2 to the base e, that is ln 2, is which one of these? You have 4 options. This is of course a single correct option question, but very soon I will be discussing questions having multiple correct options. So without wasting any further time, let me just start discussing the solution. But before that, let me tell all you people that this is quite an easy problem. Application of basic calculus will see you through if you were trying to solve this problem in your examination. So the given differential equation is this is the given differential equation. Even a children should be able to see that you can take y cube common in the numerator and e to the power x common in the denominator. So these converts the differential equation into now what we will do, what should be the next step? Very easy, as you can see. We just need to separate the variable. That's why I told you guys that it's not a very tough problem. So upon separating the variables, what do we get? So upon separating the variables, we get these. Sorry for the glitch.
Hello.
So now what do we need to do? We need to integrate straight away. And for that, we easily have, as you can see, so there is one point, because we might be changing the page soon, about which I would like to draw the attention of the student. See, this integration is pretty straightforward. There is no substitution to make, no partial fraction, no integration by parts, no trigonometric substitution, etc., etc. Very simple integration, even in an IIT problem. So going to the next page, we now have so upon completing the integration, we are left with So now we are in a position to use the given initial condition. What was that? I hope you guys remember that. That is y at x equal to 0 is 1 by root 2. So upon making use of that, as you can see, so see, very clever ways of giving the values of initial condition. From this step you should be able to do it without any problem, that k turns out to be equal to 0. So that is, the initial condition is evaluated to be 0. Now we are basically just one step away from solving the problem, but whatever complicated calculation, if any, is there in this problem, then it starts now. So I ask everyone to be very mindful about it. So with k being equal to 0, the solution now becomes with k being equal to 0, the solution now reduces to y square minus 1 by y square equal to e to the power 4x by 2 minus 2 into e to the power minus x. So now we are in a position where now we are left with one step away. We are just one step away from solving this problem. We need to find this quantity, that is the value of y at log of 2 to the base e. So instead of x, we here substitute. Instead of x, we here substitute log of 2 to the base e. So now the solution reduces to this form. I hope all of you can see these. So from these I need to shift to the next page because we are running out of space. So we need to simplify this further. For that, the next step should be that is see, with the minus sign being absorbed, I have just inverted the factor 2 into half. This is very common in the formula for logarithm. So incorporating that, this becomes half into 16 minus 2 into half, and this gives us so finally we are left with this equation, y square minus 1 by y square equal to 7. How to solve it? This is basically mathematics of class 9 and 10, and for solving this we will just make this substitution. Let y square equal to z. If we make this substitution, if we assume that y square is equal to z, then since y belongs to this interval 0 comma infinity, open interval, as I said, then z must be greater than 0, and upon making this substitution, this equation, this one I am talking about, reduces to z minus 1 by z equal to 7, which easily gets converted into. Now, this is a simple quadratic equation given in the examination of IIT Advanced of class 9 and 10 level. If we solve this equation using Sridharacharya's formula, then the value of z will be So, if you are looking at the options, then you can understand that finally we have arrived at the answer. The correct answer is y square equal to z equal to 7 plus minus root 53 divided by 2. We were interested in finding the value of y. So, y should be equal to 7 plus root 53 divided by 2, and the whole thing will be under root. This is my solution, and as you can see, because I said the students have a nasty habit of looking at the options always. So if you were looking at the options, then you have picked up that option B is the answer, but there's still an if or a but. Why did we reject? Why did we reject the solution 7 minus root 53 by 2? See, I had these plus minus root 53 by 2. The answer is too simple to be discussed, yet we should realize that root 53 is greater than 7, isn't it? Because root over of 49 is 7 itself. So 53 is greater than 49. So root over of 53 will have to be greater than 7. So if we subtract something greater than 7 from 7, there will be a negative quantity, and while finding the value of y, we are taking the complete square root of this quantity. So that means if we are considering the solution 7 minus root 53 by 2, we are running into trouble. We are considering imaginary quantities. But here, according to the condition of this problem, we are considering only real quantities. That is why we are rejecting this root. I think this easy enough condition is understood by every listener. So as you can see, option B is the correct option. And everyone should understand that it's a damn easy problem. If you would have picked this problem up, if you had appeared in the IIT Advanced 2026, if you chose this problem, then you are absolutely correct. This is an absolutely doable problem, very simple, no complication in integration, easy separation of variable. Anyone who has started solving this problem should get to this option B. In the next video, we will be discussing another physics problem from the IIT Advanced 2026.